Hi, this is Mrs. Doris. This is lesson 9-6 entitled The Quadratic Formula and the Discriminant. Our objective in this lesson is that you will use the quadratic formula to solve quadratic equations and use the discriminant, which we'll define and show you what that means, use it to find the number of solutions. Of course, the reason we are studying quadratic functions is because they model certain situations where the rate of change is not constant. The quadratic formula can find the solutions for any quadratic equation. And remember, when we talk about the solutions, we're talking about the x-intercepts of the graph of the quadratic equation. We're talking about the roots of the equation, or the zeros of the function. Those are the solutions. So the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. It's very important to remember that when you use this formula, the quadratic equation should be in the form of ax squared plus bx plus c equals 0. And be sure to note that it is equal to 0, which is a standard form of the quadratic equation, before you use the quadratic formula. Now, a good way, this is a long formula, and this is one I will require that you memorize. You need to know this. Is to sing it. And so I'm going to apologize for my voice because I am not a soloist, but it helps and it's kind of catchy. We're going to sing it to the tune of Pop Goes the Weasel. So here goes. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you will sing that several times, you can repeat this if you would like. It'll help you learn it. There is another version of the song, and I know there's a lot out there. If you Google quadratic formula song, you'll find several. This is to the tune of Are You Sleeping? And the only thing that I don't like about it is it leaves out the x equals. So I'm just going to say it and then I'll sing it. X equals, here we go, negative b plus or minus square root of b squared minus 4ac all over 2a, all over 2a. All right, I think I did a better job of singing it in class, but anyway, here it is for posterity. All right, let's continue. Let's discuss the methods that we have for solving quadratic equations. In yesterday's video, lesson 9.5, I mentioned there were 3. There's actually 5. So let's talk about those. The first one is graphing. When we graph a quadratic equation and get a parabola, if we have whole number or integer x-intercepts, that can be one way of solving the equation. Your book mentions a graphing calculator. If you use a graphing calculator, that's a great time to use it to find your solutions to a quadratic equation. The other thing I put on here is estimate. If you have a graph and the parabola does not go through integer answers, you can get an estimate. And if an estimate is all you need, then graphing can work for you. The next method that we learned in lesson 9.3 was taking square roots. Taking square roots, or finding the square roots, works if the equation has no x term, or you might think of it as the bx term. If it doesn't have that, then you can use square roots. In the next lesson, we studied factoring. And factoring works great if the equation is easily factorable. If it is not, then you may have another method that you would prefer. Completing the square will work if you can't factor it. Completing the square is easiest if a is equal to 1, and it's still easier if b is even, an even number. And that's because to complete the square, we have to take b, which is the coefficient of the x term, and divide the b by 2. And so if it is an odd number, then you're going to introduce decimals or fractions into your equation. And finally, we have the quadratic formula. And the quadratic formula is the one to use when the others aren't going to be very easy to use. I have put anytime on here because the quadratic formula will work anytime you need to solve a quadratic equation. Quadratic equations can have 2, 1, or no real number solutions. Before solving, you can determine how many solutions it has by using the discriminant, the expression which is under the radical sign in the quadratic formula. The discriminant is, and it's the part b squared minus 4ac. And when you look at that, you can determine the number of solutions. If the discriminant is positive, then there are going to be 2 solutions. That is because in the quadratic formula, you're taking the opposite of b plus or minus the square root of the b squared minus 4ac. So if you have a positive number, then you can take negative b plus that square root, or you can take negative b minus that square root and then divide by 2a. So you're going to have 2 solutions. If the discriminant is 0, then there is only 1 solution. And that's because the square root of 0 is 0. And whether you take negative b plus 0 or negative b minus 0, you're still going to get the same number. So you'll only have one answer. If the discriminant is negative, then you cannot take the square root of a negative number, and so therefore there are no solutions. And if you remember, we looked at that on the graph. That would be a quadratic equation whose graph is either above the x-axis entirely. It would have a y-intercept, or a vertex above the x-axis and then open upward, or it could have a vertex below the x-axis and open downward. All right, so problem 1, using the quadratic formula. What are the solutions of x squared minus 4x equals 21? All right, well, the first thing that we have to do before we can apply the formula is to make this equal to 0. So I'm going to subtract 21 from both sides. All right, that will give me x squared minus 4x minus 21 is equal to 0. Now that I have it equal to 0, I'm ready to identify my a, b, and c. A is the invisible 1 that's right there in the equation. All right, it's the coefficient of the x squared term. B is the coefficient of the x term. In this case, b is negative 4. And my c is the constant, which would be negative 21. All right, now every problem you work with the quadratic formula, if you will write the formula before you substitute in the numbers, you'll have it easily memorized. So here we go, and I'm going to sing it again as I write it here on the board. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, let's substitute in the values we know. All right, the opposite of b would be the opposite of negative 4, which is 4. Plus or minus the square root of b squared would be negative 4 squared. And then minus 4 times a is 1, times c, which is negative 21. All over 2 times a, and a is 1. All right, now let's start evaluating. I'm going to evaluate what I have under the radical sign first. So I'm going to bring down my 4 plus or minus. Now, under the radical, negative 4 squared would be 16. Minus 4 times 1 times negative 21 would be a positive 84. All right, all over 2 times 1, which is 2. All right, let's simplify under the radical still further. We have 4 plus or minus 16 plus 84 would be 100, all over 2. And this is a perfect square, so let's simplify. The square root of 100 would be 10. All right, at this point, what I'm going to do is I'm going to divide this into two problems. I'm going to have x equals 4 plus 10 divided by 2, and move this out of the way. I'm going to have x equals 4 minus 10 divided by 2. Simplifying each of these expressions, 4 plus 10 would be 14, divided by 2 would be 7, and 4 minus 10 is negative 6, divided by 2, which is negative 3. So my two solutions, also known as the roots of the equation and the x-intercepts of the graph, would be x equals negative 3 and positive 7. As you work with the quadratic formula, my suggestion would be is that you write out these steps. And you may think it takes a lot of work to do that, but I can guarantee you, you will have, if you write it out each time and simplify a small portion of it, you're less likely to make a mistake. Also, in a testing situation, such as our test next week, you'll earn partial credit. Even if you make a mistake somewhere along the way, I can give partial credit for partially correct work. All right, problem 2, finding approximate solutions. A batter strikes a baseball. The equation y equals negative 5/1000 x squared plus 7/10 x plus 3 5/10 models its path, where x is the horizontal distance in feet the ball travels, and y is the height in feet of the ball. How far from the batter will the ball land? Round to the nearest tenth of a foot. All right, let me draw just a quick graph of this situation. Here's the batter standing on the y-axis. All right, and I can't draw, but okay, here we go, and he's got a bat in his hand. He's going to hit the ball at that point. This ball is going to take a path, and somewhere down here it's going to hit the ground. And that point right there is going to be the solution and to our problem. So we're going to use the quadratic formula to solve this. All right, so I think I may have to erase my drawing in a minute, but I'll wait. Okay, so let's start again with our formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, let's substitute in. Now, my a is negative 5/1000. So let's write that down. A is negative 5/1000. B is 7/10, and C is equal to 3.5. All right, so here we go. X equals, the opposite of B would be a negative 7/10 plus or minus the square root of 7/10 squared minus 4 times A, which is negative 5/1000, times C, which is 3.5. All right, all divided by 2 times A, which is negative 5/1000. All right, now let's start evaluating. Okay, I've got negative 7/10 plus or minus the square root. 7/10 squared would be 0.49. Negative 4 times negative 0.005, or negative 5/1000, would be a positive 2/100. And you may want to take your calculator. In fact, I'm going to grab one right now just to verify this so that I don't make a simple error here. And I certainly encourage you to use them. So, all right, looks like I get 7/100. That's interesting. Okay, so we're going to add 0.07, all divided by 2 times a negative 5/1000, which would give us a negative 1/100. All right, let's add together what we have under the radical sign. So I have x equals negative 7/10 plus or minus negative, let's see, excuse me, 49/100 plus 7/100 would be 56/100. All right, and I am going to come over here and erase my drawing so that I have a little more room to work over here. And let's take the square root of 56/100. The square root of 56/100 would be, and I'm going to round this off to the nearest hundredth. So I get 0.748. That would round to 75/100. So I have x equals negative 7/10 plus or minus 75/100, all divided by 100, negative 100. All right, so let's divide it into two problems. I have negative 7/10 plus 75/100 divided by negative 100, and I also have negative 7/10 minus 75/100 over negative 100. Okay, so here we go. And I'm going to erase this in the center too as I simplify my answer. All right, in the numerator, negative 7/10 plus 75/100 would be a positive 5/100 divided by a negative 100 would be negative 5. Okay? And in my other expression, negative 7/100 minus 75/100, I would get a negative, whoops, should be negative 1.45, negative 1 45/100, divided by a negative 100, which is going to be 145. Now, the question is, Let's take a look at our answers. All right, one of the things I wanted to check um, before continuing is the answer that they give in the book. Um, First of all, this answer right here, -5, does not make any sense in our problem. So we cannot consider that number. Our second solution, 145 feet, this would be rounded to the nearest foot. And the teacher's book gives the answer 144.8. So I am going to leave it in this form, and the reason that I'm getting 145 is the rounding that we did on our square root of 56 hundredths. If I carried that out another digit or two, then we could round to the nearest tenth. So be aware that at that point, we have a small round off error. And depending upon the nature of what you're trying to find and how exact you want to be, you may want to carry that number out a few more digits. Okay, problem 3, choosing an appropriate method. Which method or methods would you choose to solve each equation? And explain your reasoning. Now, we're not going to solve these, but I will tell you the method that I would choose. And so beginning with the first equation, x squared minus 8x plus 12, I would choose factoring. And the reason I would choose factoring is because it's easy to factor. And I will go that far to show you. This would factor into the factors of 12 that add up to -8 would be -6 and -2. So this is easily factored into x minus 6 and x minus 2. And in fact, we can easily solve this. If x minus 6 is equal to 0, x would be 6. And if x minus 2 is set equal to 0, x would be 2. So our two solutions, we actually did solve it. That was pretty easy to do. In our next example, 169x squared is equal to 36. This is one where I would find square roots. And the reason I would use finding square roots as the method to solve is because I do not have a bx term. I'll just say the equation does not have an x term. We'll call it that, an x term. All right, and this is one where I can easily, and let's just go ahead and solve it, divide by both sides by 169. So I get x squared is equal to 36 over 169, and then I can take the square root of each side. So I'm going to continue this down here at the bottom. Square root of 36 would be 6. The square root of 169 is 13. And don't forget, I almost didn't save myself enough room here. X can be positive or negative. So here would be my answer. Positive and negative 6/13. My next equation, 5x squared plus 13x minus 1 equals 0. This is one where I would probably use the quadratic formula. And the reason is just a quick glance at it. I don't see a way of factoring it. at least not easily. Completing the square would not be a good way of doing it because the coefficient of the x squared term is 5, not 1. And so the quadratic formula will work anytime. And so would be my choice since I don't see a good way of doing it otherwise. All right, and problem 4, using the discriminant. How many real number solutions does 6x squared minus 5x equals 7 have? Okay, well, first of all, we need to get this in standard form, so I want to make sure it's equal to 0. So subtracting 7 from each side, we have 6x squared minus 5x minus 7 equals 0. Let's identify our A, which is 6, B is negative 5, and C is negative 7. All right, so to determine how many solutions it has, I'm going to go to the discriminant, b squared minus 4ac, and I'm going to substitute in the numbers I have. B is negative 5, so I want to square that, minus 4 times 6 times c, which is negative 7. Evaluating the discriminant, I get 25 minus 4 times 6 is negative 24 times 7 is 168. And my negative minus sign here and my negative here will make this plus. So 25 plus 168, and that is a total of 193. Okay, since this is positive, since 193 is positive, there will be 2 solutions. All right, if you have any questions, please don't hesitate to ask, and I will see you in class.